Texas emits about 380 megatons of CO2 a year from point sources. Louisiana, about 146. And the US total, about 2.8 gigatons. That's the scale of the challenge that we're up against. And there are, of course, a number of storage possibilities. You can store it in CO2 EOR projects, which has the advantage of being mature in terms of regulation and practice, and a dual revenue stream. But the total Gulf Coast scale or capacity scale is about 5 gigatons. We can store it in depleted fields, of course, with proven seals and the advantage of delaying decommissioning for those fields. But again, total capacity is about 10 gigatons, or 4 years-ish of US emissions. The big capacity is, of course, in saline storage, which is hundreds of gigatons on the Gulf Coast. It also, of course, offers the advantage of flexible location and potentially individual sites of really large capacity. And that's what we want to focus on. And the first two of those schemes, of course, are tied to reusing hydrocarbon reservoirs. Saline storage isn't. So the question is, the two questions that we want to address here are, well, number one, if you start with a clean slate, how do you optimize a play for pure storage? And two, of course, how do you effectively and efficiently identify and screen potential storage locations so that we can move from emissions and aspirations of storing these things to actual leasing and project development? So the play concept that we're pursuing is as follows. Now, the cartoon here, of course, is a salt diapir with a few sands that thin and pinch out onto the top of it and a gas accumulation. That same sort of buoyant trap will, of course, work for storing CO2, but we think we can do better.